We will be talking about permanent way, the requirements for the permanent way, how the various tracks are classified, and then we will also look at the various components of the single line or the double line broad gauge track. Now, here I am not talking about the meter gauge track because, as I said in the previous lecture too, the Government of India came up with a uniform gauge policy wherein it aspired to change all other tracks to the meter gauge. Of course, we will be talking about this policy later. If you want to understand, then there can be meter gauge, there can be a narrow gauge also, and apart from that, there can be a hill gauge. So, all of those slowly and slowly needs to be transformed into the broad gauge track. On right hand side, what you can see is a 4-track system which is being electrified. So, here this is track 1, then track 2, track 3 and track 4. And when I say track, it is a combination going from this to this distance, and similarly for the other of the tracks. That means there is a certain width in which a track is going to be laid down, and this width is going to be decided on the basis of the distance between the rails, on the basis of the supporting system which is being provided, which is more than the rail, and then the supporting system, which is usually known as sleepers, is resting in the ballast cushion, and that is where that ballast cushion is going to extend further in the lateral direction, and that will make out the total width of that track. And if we talk about the multiple tracks, it means there is another important aspect which needs to be looked at is the center to center spacing of those two tracks. Apart from that, if it is electrified, then there will be some distance at which the pole is going to be erected, through which the electric traction will be provided to the locomotive and the train. So, this is an overall aspect which we are going to talk in this particular lecture. So, let us start with the permanent way. Now, what is permanent way? Permanent way is also known as a track, or it is also being termed as a railroad. The road which is being provided using the rails on which the trains are going to move, and this particular terminology is mostly used in Europe. In our case, we usually work with either the word track, or if you go into the RDSO specifications, they will be talking about permanent way oblique track. How to define it? It is a path which is used for the operation of trains, and it consists of two parallel rails which are placed at a specified distance which is called as gauge. The sleepers which keep the rails in position using fastenings. You cannot leave them loose. You cannot just say that I have put the rail at the top of the sleeper and my job is over. We need fastenings to connect the rails with the sleeper so that they remain in position. And then the sleeper is, as I said, is resting in the ballast, which acts as a cushion for the rail sleeper combination. So, there is a cushion depth also. So, if I talk in the right hand side the diagram, it is a path. So, this is a path for the operation of the trains. There are two parallel rails which have been placed at a specified distance. They have been supported by the sleepers at the bottom, have been attached, the sleepers and the rails, both these are things have been attached together by use of fastenings. The rails and rails are being attached together by way of the fish plate and the fish bolts, as being shown there in that diagram, this photograph. And then the sleepers, they are extending up to this particular distance and being resting in the ballast, and this ballast cover is going to further distance on the left and right of the track. The whole of this assembly rests on the formation level prepared for the same. That means the formation level will be somewhere here. So, you have a formation level, at the top of that you have a ballast cushion, and in that ballast cushion you have placed the sleeper which is being embedded. So, the cushion is here with some extra packing on the sides of the ballast, and then at the top of that the rail is being provided here, where the two rails are at a specified distance which is defined as gauge, and that is how this particular permanent way is being created. Now, these rails are joined together by using either the fish plates or bolts, which is a combination, and this is already being shown here if you minutely see in this particular photograph, or they have been done by welding them together, and this is the one which is now being used. Nowadays, we are more inclined, or Indian Railways is more inclined for welding the rails rather than providing the fish plates and bolts, because this is one particular area which is a weak location on the track. And you must have heard that there are people who have just taken away the fish plates or the fish bolts, leaving the rails loose, and there is a possibility of a derailment of a train at that particular location. So, if you go for a welding, you are reducing that sort of possibilities. Now, when you talk about the requirements which should be there in the case of a permanent way, there are a number of things which needs to be looked at. The very first thing we are talking here is for alignment. Alignment means what? This is basically connecting point A and point B on the basis of the ground realities, on the basis of the contours which are available, on the basis of the possibility that whether the track can pass through those particular contours, so that there is no extra effort which comes to the locomotive in hauling the train or the wagons which have been attached to that locomotive. Now, when we talk about this alignment, our aim should be that it should be as far as possible straight in nature, but it may not be a possibility every time. It may not happen that we will be able to provide a track like this connecting A and B straight. Another point is the free of kinks. That means if you are talking about the two rails, so it should follow each other in the profile. It should not happen that the rail is going in this form, even though it is trying to follow each other, but then this is what is a kink here, a kink here, or these are the kink positions, and these kink positions are the positions which will create discomfort to the passengers, which will create problems to the movement of the train, and at this particular area or a stretch the train has to move at a restricted speed. So, it means it is causing problem in terms of the travel time also. Then another thing is the combination of the various components in terms of the rail, sleeper, fastenings, ballast, etc. That whole track that should be resilient in nature. It should be able to take up the loads which are coming from the top. There are locomotives. We did talk about what is the traction or the hauling capacity of a locomotive, roughly around 40 tons in the case of a broad gauge, and then it is having various number of wagons. So, it may come out to be 1000 tons of a load which is coming from the top on the rails. So, the track should be able to take up all those loads. So, it should be resilient in nature, but at the same time it should be elastic in nature, because whatever the loads are coming here, the load which is coming on the rail, it will cause some deflection here. So, if that deflection is being caused, it should not happen that that deflection remains constant in nature. So, as soon as the train has moved, the track should come back to its normal condition, and that is where the elasticity is being talked here. The another thing is related to gauge. Whatever gauge we are talking about broad gauge or meter gauge or a narrow gauge or a Hale gauge or a standard gauge, whatever we are talking, it should be first of all correct. Correct means if the value is x point y z p in terms of meters, then this y x dot y z p should be available between these two rails throughout. It should not happen that it is changing. Of course, there are certain tolerances, but there is not much variation here, and it should be uniform. The gauge uniformity is important, because if you are talking about a broad gauge and then it converts into a meter gauge, then there is a problem at this point of connectivity. You have to transship the material from this particular gauge to another gauge, and the whole of the rolling stock is also going to be different. There are different type of requirements which will be there, will also going to be different. So, that is where the uniformity is a very essential thing. The gradient is another aspect. It is not that every time the tracks are going to be laid in the plain terrain. You may be having the hills, and if you have the hills, it means you have to move from one elevation to another elevation, which is having a height of h in between. So, if you have to scale that, that means a gradient has to be provided, and that gradient can be in terms of 1 in n. So, that gradient, or it can also be defined as x%. So, whatever this gradient we are talking, it should be gentle, because the train with so much of a load cannot move on a steep gradient. So, it is better that if you are connecting these 2 points, it should not a steep one. As far as possible, we should go with this gentle one, and again these should be uniform in nature. Now, another aspect is the cross levels of the rails. The cross levels of the rails, they need to be maintained. They need to be maintained on the straight sections, they need to be maintained on the curved sections. So, whatever is the level here, the same level should be here. But of course, in the case of curved section, because the cant will be there, a super elevation section will be there on which the rail is being provided. So, there is going to be a difference in that, but then that should be with respect to this angle theta on which the cant has been provided. The lateral strength is also an important aspect, because the train which moves, there is a contact between the wheel and the rail, and the wheel and the rail, they are being having contact in terms of the flange on the wheel also. So, if we talk about a wheel, so it is a possibility in this form. So, this is the wheel, and then there is a rail being provided in this form. So, there is a contact here, but then there is always some clearance at this point. So, this is a clearance D. So, considering this clearance, there is a possibility that this wheel can move in the lateral direction and will hit on the rail head. And if these hits are repetitive, then it will create a problem to the rail head. There will be defects in that. So, the lateral strength is another important criteria, and it should be there so that it just withhold the shocks and vibrations which are going to be produced because of the lateral movement of that train. Another one is the drainage. Now, no water logging should be there. If the water is coming on this track and it is percolating into the track, it will create problems to the material which has been used here, and that is where it will create a problem to the stability of that track. So, this is also an important aspect we probably need to look at in terms of a surface water as well as subsurface water. Maintenance. These tracks can work with some gross million tons of a load in their life, and as soon as this gross million tons is being achieved or it has reached, then there may be a requirement of the renewal of the track or replacement of the various components on that track. So, whatever type of components, whatever type of fastenings we are using, they should be such that they can be easily be replaced, they can be easily be renewed, they can be easily be taken out, and then the track can be maintained in its normal condition. Whatever you do, the final thing comes in terms of the money, the cost. So, whatever construction activities are there, maintenance activities are there, operational activities are there, they should be economical in nature. That was another aspect related to the requirements of a permanent wheel. Now, if we look at here, the various types of gauges are being defined. The broad gauge, which is 1676 mm, meter gauge by the name itself 1000 mm, narrow gauge 762 mm, hill gauge is 610 mm, which is used in very specific areas, like if you talk about Nilgiris, if you talk about Darjeeling railways, there you may find, and standard gauge is 1435 mm, which is being used in number of countries also apart from India. In India, we are using in specific projects, not in all the projects, specifically not on the main routes of Indian railways. There we are working with this 1676 mm gauge, which is a broad gauge. Now, these permanent weight tracks, they can be classified, and one way of classifying is on the basis of the speed. So, here again I am talking about the broad gauge only, I am not taking up the meter gauge. In the case of broad gauge, we have a group A where the speeds are up to 160 kilometers per hour, the group B where the speeds are up to 130 kilometers per hour. There is a group C which has the suburban sections of Mumbai, Delhi, Chennai and Kolkata, so suburban railways, the urban railways. Then D is spatial where the speeds are up to 120 kilometers per hour and the traffic density is more than or equals to 20 GMT. If it is only D, then in that case even though the speeds are up to 110 kilometers per hour, but the traffic density is less than 20 GMT. And the group E where the speeds are up to 100 kilometers per hour. So, they all sections or the branch lines will come under this particular category. So, this is one of the classification of the broad gauge tracks on the basis of the speeds. So, at the moment we are talking of speed of up to 160 kilometers per hour, but as soon as we will move into the higher speed tracks which is going on, we may achieve 250 or 320 kilometers per hour also. Now, here the various components of a single line broad gauge track has been shown. You can see on the right hand side a very beautiful track is being shown which is having on a single track, single lane. Now, what are the various components? Let us start from the bottom. The formation width. The formation width is 7850 mm and this is the minimum which has to be there. It cannot be less than this. And this formation width has been provided a slope of 1 in 30 on either side of the center line. That means if there is a possibility of water coming inside, it should drain outside like this. So, the drainage has been taken care of by way of the provision of the profile which is on which this formation level has been laid. This Y is the ballast cushion. And in this ballast cushion the sleeper is being provided, whatever the type of sleeper may be there. Nowadays we are mostly working with the concrete sleeper, and then at the top of that the rails are there. The gap between the two rails is 1676, that defines it's a broad gauge. With the sleepers it is 2740 mm, that means from this point to this point. And then with the packing of the ballast being provided here along with the cushion at the bottom of the sleeper, this comes out to be 3350 mm. So, this is the total width which will be there at the top, and then the slope has been provided as horizontal to vertical of 1.5:1. So, this is the overall geometry, overall way the one single track is being provided, but this is for other than LWR CWR. Now, what is LWR CWR? LWR CWR is long welded rail or a continuously welded rail. So, if a fish plated track is there, in that case of fish plated track we are going to go with this particular type of a construction. Few other things related to this particular one is the depth of ballast cushion Y. It can have 3 values depending on the category of the track, depending on the loads which are going to be there in terms of gross million tons being transported using that particular track. So, it can be 250, it can be 300, it can be 350 mm. The margin beyond sleepers can increase to the different values. Now, when we say this margin, we are talking about the outer side. So, if it is a curved section, then this is the outer side. So, 400 mm in case the curve is sharper than 600 meter radius on a fish plated track, 550 mm on the outside of the turn in curves of the turnouts or in passenger yards, 400 mm on outside of all curves flatter than 875 meter radius on the SWR track. SWR track is a short welded track, and 450 mm on outside of all curves sharper than 875 mm radius. Here R is missing, so we can note that. So, it means on this particular outer side some variation is going to be there, and that is where the total width will increase in these conditions. Now, this is a case for a LWR track. Now, in case of LWR track, all those things remains the same. Now, what happens is this is the ballast cushion being provided below. Then there is a cess being provided on the inner side, that is B. There is a cess on the outer side, that is C, and this can change as we have seen in the case of single lane other than LWR track, and then there is a width which is going to be occupied by the ballast level, ballast section, which is D on this side, E on this side, because of the change in the C. Otherwise, the both of the values are going to be D if it is a straight track. And then there is the formation level F, which we have seen is 7,800 something mm, and then height of the overall track which will be there. So, these are the various components which are going to be there. Here you can see some of the fittings are being shown. So, these are the elastic clips are being shown at the moment, which are connecting the sleeper and the rail, which is the latest things in use. Now, here two other things are being shown. In this side we have embankment, whereas on this side we have a cut section. If it is a cut section, so 1:1 slope, then we have a straight portion, and again 1:1 slope, then the ditch is there again 1:1, and that is how it gets connected. So, the various values have been defined here for all those A, B, 2 up to H, and this is for broad gauge with PRC, means this is a concrete sleeper which we are talking here, and there can be 3 values again of the cushion, that is 250, 300 and 350. Then B is 350, that is a cess on this side. Then C here, which is going to change subjective, you are on say curve or somewhere else, otherwise it is again a constant value. Then you have a D, means on this side, and E on other side, and then F for the formation. So, as I said, 7850 mm is the minimum which has to be there, and then the height which will vary because there is a variation in the cushion. In the case of a double line broad gauge track, so here now the one another thing which is going to be added is this value J, and this J is the center to center spacing of the two tracks. Rest of the things will remain the same. You have a cushion A, you have a cess B on the one side and C on the other side, then the D and E which is on the left and right of the center line, height H, and the F formation width. These are the other things which remains the same, along with the way the arrangements are going to be there if you have constructing this track in embankment or it is in cutting. You can see here on the right hand side the two tracks which are being laid parallel to each other, and that is what is a double line broad gauge track we are talking at the moment. So, in this case the cross slope of 1 in 40 can be there if you are talking about the old formations, but as soon as they are going to be renewed totally up to the ground level, then they are going to be changed to 1 in 30, or if it is a new track, in that case also it is going to be 1 in 30. Now, these are the values. The values again, these remains more or less same as you can see here. The main change comes finally because you are not talking about the two tracks. The formation width minimum value has to be 13160 mm. That is the value which needs to be provided. And the center to center spacing of these two tracks is 5300 mm. So, this is another value which is being talked in the case of double line broad gauge tracks. Now, this J, in the case of existing tracks, it may be found that it is 4265 mm. Similarly, in the case of the formation width F, in the case of existing it can be 12150 mm in embankment and 11550 mm in cutting. So, these are there because of the old specifications which were there. Now, we are changing the specifications, and that is where the minimum value of the formation in case of a broad gauge double line is 13160 mm. Now, look at some of the requirements in terms of the broad gauge tracks where the speed is above 110 kilometers per hour and up to 130 kilometer per hour. Rails which are used, they are defined by their section. So, this is 60 kg per meter. Actually, this is how we define, and 90 UTS is the ultimate tensile strength. We are talking as 90, it can be 72 also, but here for this we have to use 90. Sleepers PSC, the concrete sleepers has to be there, and sleeper density is 1660, and this sleeper density is defined as sleepers per kilometer. Then the ballast cushion minimum is 300 mm and the clean is 150 mm. Okay, all these dimensions we are talking here in mm. Turnout switch is thick web switch. Crossing is the CMS, which is cast magnesium steel. Switch expansion joint SEJ is the improved one which is used here. The bridge sleepers, they are H-beam or composite sleepers, and the level crossing can be there. If it is there, it has to be interlock type. But if we change the speed above 130 kilometers and up to 160 kilometers, there are few things which are going to change. This remains the same. Here this is wider, heavier concrete sleeper which is being used with the same sleeper density. The ballast cushion remains the same. The turnout switch we have the same. Here the crossing is weldable CMS, that is the change which is coming, and then H-beam or composite again remains the same, but in the case of level crossing is not being provided if the speeds are higher. So, there are few changes with respect to the speed, many of the things will remain the same. There are few considerations on the curves. In the case of curve, proper transition curve has to be provided along with the circular curve which is there. Then maximum permissible cant is 165 mm. While considering the maximum cant access for the slowest moving train on the section. So, this is the subject condition. So, with respect to this particular condition, we are taking the maximum permissible cant of 165 mm. And of course, these values of cant etc., we will be talking when we will talk about the alignment geometry, curve design, horizontal alignment, all those things again. Then in this again another thing is the cant efficiency of 100 mm and 165 mm cant with the maximum permissible speed on 1 degree curve come out to be 160 km per hour. But if it is changed to 2 degree curve, then the speed will reduce to 130 kilometers per hour. So, that is how few of the changes are there. Obviously, on the basis of the way the geometry has been provided, the speeds will also get controlled, and these permissible speeds, maximum speeds, these again we will be talking when we will take up the alignment and the geometric design in one of the module. So, with this we will close this particular lecture. So, what we discussed today? We discussed about the permanent way, we discussed about the requirements of those permanent ways, the classification on the basis of the speeds, the requirements for the single lane and the double lane broad gauge tracks, and so this you can just make it as a broad gauge track. And the next one, in the coming lecture, we will start with the gauges in more details. Today we just talked about what is the distance for broad gauge, meter gauge, narrow gauge, hill gauge or a standard gauge. So, rest of the things we will be taking up in the next lecture. With that, thank you, we will meet again.